G'day everyone, how you going? Quick video here on our Test 5 sequences and series. General answer here is people did really well. Sequences and series for method students should not be a difficult concept. Once you've got the hang of it, terms, series, sequence, sum to infinity, it's not that hard. So I'm glad the the results were really good. Our best friend Saul Ushin has done his test here and he's done very well. Got 100%. Going to be real quick on getting through these because I don't think anyone would have a problem. Working out T1, really what I've got to do is say, well, from T4, isn't that 3 jumps backwards to get to T1? And isn't each jump 6 units? So T1 would be T4 minus 3 lots of D, jump on back, equals minus 28. Easy. A formula now, 14 in terms of n, that's saying non-recursive. This formula up here was a recursive formula. It's asking for the non-recursive version of it. Oops, too far. And there we go for it. Okay? We already knew our starting term and we knew the difference. So we had all the info from upstairs. We just needed to put it together. Oh.
I think when you turn around.
There we go. Okay, we're back. Either is going to be fine. Either is going to be fine. Okay, doesn't matter. It's probably neat to simplify it out, but doesn't really matter. Working out T100. Now, if you had this already set up, okay, then this was easy. If you didn't get this, this was going to be really hard. So there's the answer there. 6 times 100, 600, minus the 34, 566. Easy marks, easy mark. Question number 2. Terms of sequence can be given by this general rule. Now remember, read out of here. 5n, that's saying the constant difference is 5. Plus 5n, that's saying constant difference is 5. This is not necessarily the starting term, because if I put 1 in here, then I get 8. That's the starting term, isn't it? T1 equals 8, which is what I've done here. Okay? Next one. Sequence is given by that one. Okay, so it's recursive. Recursive, referring to the term before. Starting term is T4. It's easier if they give us T1, but they want us to work backwards. Now, look at this. I rearrange this formula to get Tn minus 1. That's the term before. Is equal to Tn, the current one, minus 1, divided by 2. Okay? Now see, this is not this. This is the term before. This is the current term, its value, minus 1. So this is going to help me to get backwards, and then all I've got to do is use that, minus 1 off here, divide by 2, 15. Minus 1 off that, divide by 2, 7. Minus 1 off that, divide by 2, 3. There are my numbers. Okay? Easy, easy. Question number 3. A non-recursive formula. Write a recursive rule. Well, this minus 3n part, the minus 3 is my d. So that's got to go in here. And then I just need to work out term 1. There we go. Easy. Not much here to worry about. A term of this sequence has a value of that. Well, you could use this one, but you'd be there for a while. You could use this one, but you'd be there for a while. Easier to use this one. Put the 757 in, work your way through 81. If you want, check it back the other way. Put 81 in here and make sure you get back to 757. Easy. How many have a value greater than 0? Okay. I'm letting it equal 0. That's not actually a term of the sequence. But if I let it equal 0, I end up with this. Divided across, it would actually be 333 and 1/3, right? Now, if I went to the 334th term, I'd be less than 0. How do I know that? Well, it's going down, isn't it? So if I'm to round up, I'll actually be past where I want to go. If I round down, I'll be before where I want to go. How many terms have a value greater than 0? I want to be there, don't I? That's where I want to be. All right. Next question. Sequence is defined as. There we go. It's recursive. I've got a starting term. First 4 terms. Nothing hard about that. Answers are there for you. circle the correct non-recursive formula. It's a matter of just trial and error here. It's a bit of trial and error to say, well, look, if I put 1 in, what do I get? 2 in, what do I get? A little bit of trial and error. The last one at the end there. Find the 100th term. Well, now that you know that, can't I just put 100 into there? There were a few mistakes here, people forgetting how to square 100. It's 10,000. 1 times 1 is 1. Add your 4 zeros, done. And then add another 150. Few errors there, but they were just arithmetic ones. Okay, section number 2. Here we go. So, given that a sequence is geometric and we've got these two going on, yeah, see, we're tricky. You can't just throw that into your calculator. Well, you can with some of your activities, but I can work out my R value. I get 4. Now, be careful here. Could this be negative 4? No, it can't be, because if I took T3 and multiplied by a negative, T4 would be negative. T5 would be positive. T6 would be negative. Well, it's not. So because these are an odd spacing, 3 apart, I can't have a negative here. If these were an even spacing apart, then I could have had a negative here. Okay. So T8, how do I get T8? We'll start at T6. Just go on 2, see guys, just go on 2 extra steps. Times R squared. Easy. Bit of number crunching, we're there. Simple, simple. You guys go, go. I'll finish the video. Here we go. So S10, all we need to do is take the information that we just got from here, the R equals 4, and put it on in. That's all. I did have to work out A as well. I had to work backwards to get that. Nothing too tricky in that. You've got your calculators. Back you go. 1,048,575. Question number 5. Here we go. Geometric progression. Geometric. Constant multiplier. Must be constant multiplier. What am I doing? It's getting smaller. So I've got to multiply by a number less than 1. How can I get it? This one divided by this one. 27 divided by 81, 1/3. 9 divided by 27, 1/3. 3 divided by 9, 1/3. That's how I get this. Working out T5, well, we've got T4, just multiply by 1/3. There we go. Equals 1. Easy one. Which term of the sequence is the first to be less than that? Now we need the calculator. This would be tough to do without. Put in 0.0001 here. Solve. I get this number. Now I've got to decide whether I'm going to round up or round down. Which term is the first to be less than? Less than. Now the sequence is going down. So if I was to round this to 13, I wouldn't have yet got there. I've got to round to 14. Okay? Now if you're unsure, it doesn't matter. Your calculator will save you here. You have the formula. You have the formula. Put 13 in, see what you get. Put 14 in, see what you get. Pick the right one. Easy, easy. Use that calculator of yours. Can you calculate S to infinity? Well, way back up here, we figured out that R was 1/3. Now, when you're going to calculate S to infinity, the R value has to be somewhere between 0 and 1. 1/3 is perfect. So, yes, I can. If you can do so, here we are. Don't worry about the rest of it. I don't need to explain because I can do it. Here we go. Here we go. Here we go. Easy, easy. Number 6. Now we get into a bit of practical questions. These are often the trickier ones. The rocket's fired up in the air, 10 metres, 8 metres, 6.4 metres, 5.12. Sounds like a sequence to me. It's definitely not arithmetic because the amount is changing. Must be geometric. Sketch it up. Worked out that R was 0.8. This divided by this divided by this, etc. Same as that question above. How far does it travel in the 15th second? Well, I've set this up so that the n number is the second number. Okay? So this is the first second, this is the second, this is the third. So I just want to work out T15. That's all I need. There's the number crunching on the right. Round it. Well, it says correct to 2 decimal places. Here we go. I gave this answer. I just rounded it to 44 as well to say, wow, it's pretty close to 44. But 2 decimal places would be 43.98 centimetres. How far has it travelled after 10 seconds? That's summing up all the distances, isn't it? Isn't that just S10? I've already got most of the numbers for here. In they go. 44.63 metres. Sounds kind of right, because remember it went 10 and then 8 and 6.4 and 5. It's definitely dropping off. So that sounds about right, 44.63. I like that. What's the maximum height? Well, because, again, this is an R value between 0 and 1. So yes, I can figure out S to infinity. And here we go. 50 exactly. Does that mean it reaches 50 metres? Well, theoretically, no. It gets really, really, really close. Now, in a practical sense, this is a rocket, right? In the last couple of seconds before it kind of hits its peak and then starts falling back down, is it going to get to 50? No. The wind and a whole lot of other things are going to play into it. It gives us an estimate. That's really what it would do in this case. Last question. Susan started working as a teacher. That's her annual salary when she started. Increases by $4,200 per year. Arithmetic. I'm adding $4,200 each year. Here is my formula. T then equals A plus N minus 1 times D. Easy by now. What am I doing? 7th year. In goes 7. 84,200 is what she would get paid in her 7th year. What was the total over 11 years? We need this one, the arithmetic sum formula. Numbers in 880,000. Your calculator would spit this out for you. Because these were all 2 marks, you could have just written the answer. Calculator, answer. If it was 3 marks, you need some work. 3 marks, show this. But for 2 marks, you could have just done answer only. At the same time, my friend Victoria started working as a nanny, earning 52 in her first year, with an increment of 5.5%. Geometric, isn't it? It's got to be geometric. 5.5%. That's telling me geometric. My R value is 1.055 because it's getting bigger, isn't it? Getting bigger, right? So here we go. And then T10, 10th year. There we go. Now then it says at the conclusion of the 11th year, a bit of a trick here because don't just pull that figure 84, that's not the one you want. At the conclusion of the 11th year, who had earned the most? Well, up here, we already knew what Sue, I think this was, Susan. We'd already known what Susan had earned over 11 years. We already know her 11-year total salary. We just don't know Victoria's. So we've got to use the S to the N for a geometric series, and she came out at 758,342. Now we already knew Susan earned 880, so therefore Susan earned more. 2 marks for this, 1 mark for your conclusion. And that was the end of the test. Most people found it quite easy. Our average was up in the 80s, as it should be for this. There was not much difficult in here, not much at all. I could have put a couple of more difficult questions in, but I honestly think you guys would have got them anyway. Any questions on this, please come and see me. Hope this video has helped. Catch you guys later.